Hello, my name is Rufan, and today I'm presenting my low-cost multi-model AI UAV search and rescue platform. The starting point of this project came from two real events that happened close to me. The first happened in our community. An elderly man had came all the way from China to visit his grandson in the US. One day, he went out alone for a walk and never returned. The police were called and volunteers from the community joined the search. But it wasn't until 3 days later that he was found. Tragically, he had passed away not far from a hiking trail. The second event happened last summer, when I was at an internship in Texas. I personally experienced one of the most severe floods the region has seen in decades. Later, I learned that it was the worst disasters in Texas in recent years. Several children attending summer camps lost their lives in that flood. These two events have made me realize that finding missing people during disasters remain an unsolved challenge. We have search and rescue dogs, helicopters, and many advanced technologies. Yet we still lack a solution that is low cost, widely deployable, and less constrained by environmental conditions. That was when I started thinking about UAS, unmanned aerial vehicles. UAVs have already been used in many scenarios today. However, their primary application is still surveying and mapping. When it comes to real search and rescue operations, they face three fundamental challenges. First is the limitation of the flying camera. Standard drones can only capture top-down images. Anyone trapped under trees or inside buildings are simply invisible from above. Second is the latency trap. In many cases, data isn't processed until the UAV returns. That means the analytics aren't truly real time. And in search and rescue missions, every single second counts. Third is a needle in a haystack problem. UAVs must fly at certain altitudes to avoid obstacles. From that height, a person may only appear as a few pixels. Traditional object detection struggle at that scale. During the Texas floods, for example, some people survived by clinging to trees for hours before being rescued. From a camera alone, spotting someone in that situation is incredibly difficult. So, how do we solve this? The idea is simple. What if UAVs could work like search and rescue dogs? Why are rescue dogs so effective? Because they don't rely only on sight. They use their sense of smell, they use their sense of hearing, and they can combine multiple senses to make intelligent judgments. But rescue dogs also have limitations. For example, when floods happen, they cannot cross deep water. When terrain becomes inaccessible, they are also restricted. To address these limitations while keeping the same effectiveness, I've envisioned an SUAS, a small unmanned aerial aircraft system powered by AI, a multi-sensory edge computing real-time aerial search platform. It is a system that isn't constrained by terrain and can see, hear, and sense the presence of survivors, just like a rescue dog, but from the sky. After months of research and testing, I've turned that idea into reality through a prototype in both hardware and software. The core of the system is three different modalities: computer vision, audio sensing, and RF monitoring, all of which runs directly on board the UAV on an NVIDIA Jetson Ornia NX computer. The vision system uses two models, both of which are heavily optimized to run on board the UAV in order to eliminate latency and dependence on the cloud. My first model is a custom vision transformer. Time is critical and we cannot blindly search all areas. Instead, the system uses this model to get a quick overview of what is going on below. It knows if the area is flooded, in which case a further search is needed, or isn't flooded, in which case we can move on quickly to the next area. This model uses a custom sliding window transformer with a custom feature pyramid network neck and decoder inspired by ASPP from the well-known Google Deep Lab V3 model. The second computer vision model is a modified YOLO object detection model deployed to look for human figures on the ground. My modifications to YOLO allows to detect very small figures that may only be several pixels wide confidently, with no cases of false positives in testing. These figures are so small, as you can see, that most humans can't even see them. As I mentioned before, there's more than just vision. First, I use a 4-microphone array that can detect the angle of the sound using algorithms, as well as filter out the propeller noise from the UAV. This microphone listens for human calls. The second is radio frequency monitoring. Many victims still have their electronic devices, and even if they aren't connected to the internet, my method can still detect them through walls and other opaque barriers. We listen for both Wi-Fi probe requests as well as the presence of Bluetooth communication. Both of these can occur even if the device isn't connected to Wi-Fi or any other Bluetooth devices. The RSSI, the received signal strength indicator, tells the UAV roughly how far the signal strength is. I conducted 2 real-life tests for these methods of making the invisible seen. The first was by audio detection. We used a speaker playing a recorded human voice on a box. The second was for phone RF signals. I used my phone, even though it wasn't physically visible or connected to any networks. Before I close, I want to say this. This is more than just a technology project. Behind it is the elderly man who has lost someone off the trail and the children stranded on the rooftop waiting for help that hasn't come yet. A drone that can see, hear, and sense people who need us the most, so that we can find them, the ones we cannot afford to lose, before it is too late. Thank you.